All right, the next section explores perfect square trinomials and factoring those. So again, referring back to what we said perfect square trinomials were, those are the result of multiplying a binomial by itself. So something like x plus 2 squared, or the quantity r minus 5 squared. So in this case, we're looking at the trinomial. We can tell they're perfect square trinomials because there's a perfect square here as the first term and a perfect square here as the last term. And we can tell that that came from multiplying a plus b, that quantity, by itself. And the second one, since we see a negative sign here, we see a perfect square here and a perfect square here, we can tell that this trinomial was the result of multiplying a minus b by itself, or squaring it. So down at the bottom here, we see a couple examples with actual numbers involved. We can spot a perfect square trinomial if we see the first term and the last term are perfect squares. So let's just kind of ignore this middle part. So I'm looking at a perfect square trinomial, and I can tell that it was the result of multiplying the square root of x squared, which was x, square root of 16, which is 4, and because this one is all addition, I can tell it was the quantity x plus 4 squared. If you're not sure, you can always go and check. X plus 4 multiplied by itself results in, using FOIL, x squared plus 4x plus 4x plus 16. 4x and 4x add up to 8x. So we can tell we have the right factorization here. The second one, this one has a subtraction sign or a negative sign in the middle, but it has a perfect square here and a perfect square here. So ignoring all this notation here, this was the result of squaring x squared of x squared is x, the square root of 9 is 3. So that was the reason this trinomial was the result of squaring x minus 3, the quantity. So looking at a few examples, in example 2, we are just factoring perfect square trinomials. We're not trying to solve anything. These are not actual equations yet. So let's take a look. In A, we see we have a perfect square trinomial because there's a perfect square as the first term and a perfect square as the last term. It has a subtraction sign, so we know it was this trinomial was the result of multiplying, let's see, square root of x squared is x, square root of 64 is 8. So this trinomial came from squaring the quantity x minus 8. Taking a look at B, this is a perfect square. Both 4 and y squared are perfect squares, and of course 9 is a perfect square. This one also has a subtraction sign or a negative sign there, so we know it was a difference. Square root of 4y squared is 2y. Square root of 9 is 3. So this trinomial came from squaring 2y minus 3. Looking at part C, we see a perfect square here and a perfect square here. We have a plus sign here, so we know this was the result of squaring a sum. The square root of 9s squared would be 3s. The square root of t squared would be t. So this factors out to this. In other words, if I square 3s plus t, if I multiply 3s plus t times itself, it will result in this trinomial. Our last one, now this one's a little more complicated because if you look at the trinomial, we have to get used to looking for if there's any common monomial factors we can factor out of the terms, and it turns out there is one. -3 is a factor of all 3 of the coefficients here. So we're going to first factor out -3. So -3 comes out. -3 times z squared is -3z squared. -3 times -8z is positive 24z, and -3 times positive 16 is -48. So we have just pulled out the greatest common monomial factor from the original trinomial. Now we're going to look at the remaining trinomial and factor that. This now is a perfect square trinomial. Z squared is a perfect square, and so is 16. You'll notice before there were no perfect squares in those terms, but now that we've factored out the -3, we see we have a perfect square trinomial. So this one has a minus sign in it, so we know it's the result of squaring a subtraction or a difference. Square root of z squared is z. Square root of 16 is 4. Now the -3 is also a factor of the original trinomial. So the final factorization of this trinomial is this expression. If I multiplied, if I squared z minus 4, I would get back to this. If I multiplied this by -3, I would get back to my original trinomial. So this is the complete factorization of trinomial for example D. Now we have a few checkpoints. Checkpoints 5, 6, 7, and 8 are yours to try at home, and we'll discuss those once again in class tomorrow.